I'm Charlie Szoradi, and I'm here with Limaye, the chairman of OEM, that's Online Energy Manager, to talk about their incredible breakthrough with algorithms that support an ECORE platform. Dilip, tell us just to start with some 101 on air conditioning. What is a central cooling system with a chilled water loop?
A central cooling system generally has a chiller or a set of chillers combined with fans, pumps, air handling units, and cooling towers. The chiller essentially generates chilled water that is sent to the building's users, whether it's a hospital or a hotel or an office building, to cool the various rooms where cooling is needed.
And the chilled water loop, is that a subset of a central cooling system?
Yes, the chilled water loop is a subset of the chiller system. The chiller itself consists of a compressor, a condenser, an evaporator, and an expansion device. And then the chilled water loop goes through the evaporator back to the building where the cooling is needed.
When it comes to the bottom line for someone that is outside of the knowledge of HVAC, call them a CFO, what are the net typical savings you're able to achieve with this algorithm?
We have 17 installations currently working, and we've been able to achieve savings in the range of 20 to 40% of the cooling energy consumption.
Now, the little I know about air conditioning is that it's typically the largest consumer of energy in a commercial building, sometimes 30, 40, even 50%
Right,
or more.
depending on the type of the building, it can be 30 to 50%, and of course in warmer climates, hotter climates, it is even more. Particularly in buildings that operate around the clock, such as hospitals, hotels, shopping malls, and so on, where the cooling energy consumption is definitely the most important part of the total energy consumption.
So if air conditioning was half and you're saving 20%, you're talking about taking a net 10% off the operating cost of something. Could be a hospital, could be a hotel, one of these facilities. That's a big number.
It's a big number.
As an architect who's been at this energy intelligence for 30 years, I understand enough to be dangerous. But what's interesting from what I've understood in reading online about OEM and the algorithms, you're taking something that's very complicated and dynamically creating efficiencies. So talk a little bit about how that works.
In practice, the different components of the chiller system do not necessarily work well together, kind of do not work in sync. And by using an algorithm to optimize how they operate well together, we are able to achieve substantially increased efficiencies.
Right.
Our technology is based on the fact that there are major parameters that influence the consumption, the energy consumption in a chiller system. These parameters all interact with each other. So what we do is to optimize these different parameters so that we can achieve substantial reduction in energy in the chiller itself. The chiller's energy consumption is primarily in the compressor, and that depends on the ratio of the outlet pressure to the inlet pressure, P2 over P1. So if we reduce P2, then we can substantially reduce the energy consumption in the compressor, which is about 80 to 85% of the chiller's energy consumption. And that's what our algorithm does. It takes into account the external conditions like temperature and humidity, and the internal requirements for the load, which is the cooling requirements by the user, and adjusts the condenser water entry temperature and the loading on the chillers in such a way that they operate as close as possible to the manufacturer's specification, and we do this dynamically and continuously.
When it comes to the cost, people always ask, what's the return on investment? Is the payback inside of several years? Because renewable energy and tactics such as solar and wind sometimes have, 7, 8, 10-year paybacks. Where are you with the algorithm typically there?
The advantage of our technology is that we've been able to achieve paybacks in the range of 2 to 3 years, which is much more attractive than investments in renewable energy or investments in things like pump replacements or additions of variable speed drives. So by using the existing system but optimizing the way it works, we are able to achieve substantially increased efficiencies.
it sounds like, if I'm interpreting this correctly, you don't have to replace the hardware of the equipment. The chillers are going to stay intact, and there's not going to be a disruption to
That is
to
correct.
that hardware.
One of the major advantages of our technology is that totally non-intrusive. Does not require substantial additions of equipment, does not require stopping the operation to install our technology, which comes in a package called a PLC controller. That controller is installed on site and hooks into the existing system and simply reads data from the existing system either directly or through a building management or building automation system that might already be in place.
So is it the size of a shoebox or a carry-on piece of luggage? How big is that system that you
It's a
put
little
on?
bit bigger than a suitcase. That's the size of the panel. And then we add to that a simple computer screen. And those two items are installed on site and hooked through what is referred to as an Ethernet cable into the existing building management systems or building
Terrific.
automation systems that have the data already in there.
Now, you mentioned building automation systems. I've heard of them referred to as, BAS or sometimes BMS for building management systems. Are those interchangeable terms, or is there a difference between a
There are
BAS?
slight differences. A building automation system does more than a building management system, but their basic purpose is to monitor and manage the user's requirements for energy. So building management systems generally have sensors and controls for what would be thermostats or lighting controls and sensors, and they also do fire safety and other matters. They would also have some set points for the chiller system, but these set points are set once, so they are static, and they're not changed as the external requirements and user requirements change unless the operator intervenes and makes those changes.
Understood. And I know that in some of the conversations I've had leading up to this discussion, people were concerned that they'd already paid for some of this, that they had a building automation system, or they were working with maybe a company that has talked about creating the efficiencies, and they were concerned that this might disrupt something with their existing intelligence that's on the platform.
Well, our understanding of building management system is that it reduces energy consumption by controlling the user's requirements. So they can reduce the cooling needs or increase the heating needs, whatever, based on changing settings on the thermostats and so on. Once they do that, what our technology does is simply decides how to best provide that cooling requirement with the least energy and the least cost. So we assume that the user requirements are given or are changed by the building management system, but we then provide whatever the user needs using the existing chiller system with the best possible configuration, best possible parameters that will optimize the operation.
So if I'm hearing it correctly, they can keep their BAS or their BMS intact, and you are enhancing what it is already doing.
In fact, it helps us to have a BMS in there because the BMS already has a number of the data points that we need for the optimization. So we simply hook into it and read their set points and other data that we need, but we automatically and continuously change those as needed based on outside temperature and the changing user requirements.
Let's talk about the cost and how people can pay for this. I know that if it's inside of this 2 to 3 year payback, is there an upfront cost, or can they get some benefit from paying on the savings that are generated?
We offer two options for payment. The first option is a one-time payment, which is based on us guaranteeing the savings. And once we show that the system has been installed, is functioning, and meets the guarantee that we've provided, then we get paid a one-time payment based on a guaranteed payback. So if we say the payback is 2.5 years and the savings are $100,000, then our pricing would be $250,000. If our savings fall short, then appropriately the payment will be smaller. We also offer an option for them to have a maintenance and service contract if needed. Most of our installations do not need much servicing, but if the user feels more comfortable, having a service contract will also provide that as an addition. But the second option does not require any upfront payment or any one-time payment. It requires a payment from the savings, from the operating cost savings. So we do not charge anything upfront. As savings are realized, we measure those and we base our payment scheme on a quarterly payment as a percentage of the savings achieved. So the user has no capital investment or CapEx requirement, and they're paying out of operating savings or OpEx so that they're always cash flow positive and never have made any investment and yet are recouping the savings.
And that's a performance compensation structure, right?
It is-
You perform and they
It is
and they
based on
pay.
performance, and it is based on a one-time measurement of the savings achieved, and then based on the savings, once we agree, a payment schedule is made for about 4 or 5 years.
Dilip, sometimes people need to understand something that's new with an analogy. So as an example, if I'm understanding this and there are multiple chillers in an array for a particular size building, if I used a wheelbarrow as an example, I could hold at my wheelbarrow 50 pounds of mulch. If I brought a friend over that had a wheelbarrow, and that would hold also 50, maybe my wife says, Charlie, we need to move 75 pounds of mulch. Well, if I loaded mine to 50 pounds, which is capacity, and the other only had 25, I'm working harder, and the other wheelbarrow driver is doing less work. Now, if I'm hearing it right, and correct me if this is one of the aspects of what OEM can do with the ECORE, would you balance the load between the wheelbarrows? Is that something that's relevant, or is that kind of a stretch?
No, the balancing the loads is in fact one of the things we do, but the most important thing to understand here is that chillers, the chiller compressors, unlike motors and pumps, do not operate most efficiently at full load. So if you have a motor, its maximum efficiency is when it's running at 100% load, even 101, 102% of the load. Similar with pumps. But with chillers, the efficiency curves are quite different. They do not operate most efficiently at maximum loads. They operate most efficiently at somewhere between, say, 50 or 75%, 50 to 75% of the load. So part loading the chiller makes it more efficient. And what we do is, since most chiller systems have multiple chillers, and they always have a backup chiller, even if it's a single chiller system, that we allocate the loads to the multiple chillers in such a way that we're taking advantage of the chiller efficiency curves and trying to optimize the entire chiller system by operating the 2 chillers or 3 chillers at their best operating conditions.
So in that analogy of the wheelbarrows, if there was a third wheelbarrow on the job site, instead of Charlie has 50 pounds and the next guy has 25 with 0 in the other, you might spread out 25 pounds per unit in effect.
If all of you had efficiencies in such a way that 50 pounds are less efficient than at 25 pounds,
So
that's how it would
you're
work.
understanding what the efficiency, by reading the specs, understanding the deep dive.
We have the
It's
manufacturer specifications for efficiencies as well as the properties of all the refrigerants programmed into our algorithm.
And does just to jump on this a little further, is the typical building that would have, say, 3 or more chillers going to load typically the first one to capacity and then have overflow, or how are they typically set up?
Well, I can't speak for the operators, but my understanding is that the operator will first load up the first chiller until it reaches a capacity, and then if the load is greater than that, he'll load the second chiller, and so on. Partly because the operators feel that by bringing a second chiller on, they have to also bring on a pump and a fan with it, and therefore there is some additional energy consumption. But what they fail to realize is that the additional consumption of a pump or a fan is a lot less than the efficiency improvement by bringing the second chiller on part load. And by running 2 chillers at part load, you're better off than running 1 chiller full load and the other one at 0. The dew point temperature determines how rapidly the cooling tower can evaporate the water coming from the condenser to take away the heat and dump it into the atmosphere. And that depends on the humidity and the temperature. And the ability of the cooling tower to take that heat away, because the whole idea of a chiller system is take the heat away from the building and reject it into the atmosphere. And the chiller system essentially does that. The rejection of the heat in the atmosphere depends on the temperature and the humidity.
Okay,
So we monitor that all
Great.
along.
Well, I was just so I can really get it into my head too. If the automated script of, say, if-then statements for a facility manager loading a chiller and then having it relay over to the next does not take into account other factors, they may think that they have a level of automation and efficiency, but they're not taking full advantage of
Well,
the dynamic factors.
They would have the information on the external conditions, but the point is that these things keep changing from time to time, and unless the operator is continuously monitoring and changing everything and trying to optimize it, it is very difficult for him to do so. What our technology does essentially is does that automatically and takes away the operator intervention required to make changes in these parameters on every 5 or 10 minute basis.
So 5 or 10 minutes sounds terrific. And I know with artificial intelligence, there's this whole general movement now over these last few decades into how can we make machines smarter and machine learning. It sounds like what you're doing with this data, and it's sort of big data, right? You're capturing lots of points of information, is what might take several people multiple hours to do in a continuous level versus having the algorithm do it in effect for the building.
That is correct.
Let me give you another analogy and see if it resonates. If I have a car and it has a pressure setting on the tires, I have read that it's better to have a higher pressure in the winter than in the summer for maximum fuel efficiency. It would be hard for me to adjust the air pressure manually every 10 minutes to get maximum fuel efficiency. Are you telling me this is like a car that would have air pressure adjusted as the temperature changes?
If in fact the energy consumption of the car or the mileage per gallon of the car depended that heavily on the tire pressure, that's a good analogy. I don't change the air pressure in my tire except maybe once a year.
when it looks low.
Or when the sensor tells me it's too low.
Right. But what I'm, I guess, trying to convey to the people watching is like, there are things the algorithm is doing that a human would be at a massive stretch to achieve because of this 10-minute touch.
Yes.
And that's pretty exciting.
Or you find it very inconvenient to do so on an ongoing basis. I mean, I wouldn't want to stop my car every time the temperature drops by 10 degrees and adjust the pressure.
And at a hotel or a hospital or some 24/7 operation that's typically, over 50,000 square feet, and I read 200 tons of cooling as sort of a target minimum. Doing those things, it's not just like some extra time. It might actually not be within human capacity to be able to take so many data points and determine which one at which time is relevant for that type of system.
That is correct. To determine which parameters should be changed on an ongoing basis. In one of our installations, we were integrating our technology with the Johnson Controls Metasys building management system. We had to essentially read about 300 data points from the building management system into our system. And our requirement in the installation and commissioning was to make sure that all that information was properly being read by us. And of course, we have the manufacturer specifications in there also. So all of that information is then processed automatically by our intelligent algorithm.
And some of those data points would include thermostat settings in different parts of buildings, all kinds of things.
By part loading the chillers, we are letting them operate at less than 100% all the time, which also can extend their life.
So that's right. If you're running a car at extreme RPMs, you're going to burn out at some point the engine. So you're saying you're running it at lower than full capacity.
Correct.
You get some extra life in terms of years out of the equipment. Let's talk a little bit about the competition, or what may not be direct competition, but companies or technology that is presenting solutions that might be similar from the eyes of a facility or an operating officer at a business.
We don't think there's anywhere that actually does offer a solution with a guarantee of savings based on optimizing the chiller system operation. Now, there are companies like Siemens, someone called Optimum Energy, and others, and we have compared our technology with theirs. We have found that they do sometimes require additional equipment to be installed, so they're not non-intrusive like we are. And they generally do not offer any performance guarantees, which is one of our major advantages. And as far as we know, we have done a comparison not only by ourselves, but also have had independent third parties evaluate their patents against ours to see what they do versus what we do. And we believe that we are quite unique in this market. And we've actually done a detailed comparison, a technical comparison of our technology against 3 or 4 others to show what we do versus what they do and how we can achieve greater efficiencies.
Let's spend a little time talking about the ideal type of facility that could benefit most from the OEM ECORE technology. So knowing that it's cooling, let's assume that heat on the outside air temperature becomes one of the factors.
Obviously, anything in a very hot climate, like in Saudi Arabia or Dubai, would be better than something in Minnesota because they require a lot more cooling.
Fair enough.
But also, any facility that requires cooling on an ongoing basis, 24/7, like data centers or hospitals. Hospitals, even in the coldest weather conditions, may require some internal cooling because of the internally generated loads with the patients and with the equipment.
I was going to say, we're like furnaces, right? Humans are outputting heat, and there's also a lot of electronics in a facility like a data center and
Data
a
center,
hospital.
yes. So anything that is equipment intensive and people intensive generates internal heat. So our ideal facilities are those that run many hours, 24/7 of course being the best, and that have significantly large chiller systems. Now, we say minimum of 200 tons, but we've seen systems as high as 1,000 tons or 2,000 tons. And our biggest installation was at a district cooling plant, which had 25,000 tons of chillers,
Oh.
10 chillers of 2,500 tons each. The larger, of course, the better for us in a sense because we can do more there. On the other hand, some of these larger systems are already quite efficient, so the savings potential is not quite as high as, say, a 2,000 ton system in a hospital.
So let's go down the checklist for who's appropriate. So a facility that has a central cooling system
Correct.
with a chilled water loop.
Yes.
Check that box. A system that has over 200 tons
Of installed capacity.
which translates, I believe, to about 50,000.
Well, it depends on the
square
type
feet.
of facility. I mean, for a hospital, it might be 50 or 100,000. For an office building, it might be 200,000 because of the fact that the office building does not run more than 10 hours a day.
Understood.
And maybe only 5 or 6 days a week. So, but we have a table that shows what is kind of the minimum size.
So central cooling system with a chilled water loop, 200-ton capacity.
Capacity.
The longer the hours, the better.
The better,
So
right.
more than a
So-
single or double shift. And then maybe warm client.
Warm with the climate, the better. Yes.
We hit all 4 of those,
Right.
and off we go. And if they have a building automation or management system, that isn't a factor, but it doesn't hurt either way.
It is not a requirement because if there is none, we can still come in and install our own controls and sensors. But if it is there, makes our job a little bit easier because they're already collecting some of the data we would need anyway.
When it comes to just saying go, I know that in some of the conversations I've had, they're anxious. You know, something that's new that they haven't heard from, let's say, a trade magazine or some industry conference about doing. They don't often like to go first. So are you able to share with prospective interested parties case study or testimonials from some accounts? Because I think that goes a long way to build confidence.
We do have on our website several testimonials and case studies, including graphics showing the actual savings achieved, showing the before and after energy consumption on a daily basis.
Dilip, tell us a little bit about some of the steps that you take engaging with a customer for this incredible breakthrough algorithm.
The first step is for the customer to provide us some basic information on the facility, such as how many hours does it operate, is it 24/7 or 10 hours a day, the size of the chillers that are installed in the facility, maybe the square footage, and the general operating conditions in terms of who operates the system, whether there's a building management systems in place or not. Most of this information the user can provide within a few minutes because it's readily available. We also would like to get the billing data for the total energy consumption of the facility, and if possible, if available, the percentage of that energy is in cooling, which we can estimate, but if the user provides that, that would be better. With that information, we are able to come up with a preliminary estimate of what the savings potential is. At that point, if it appears that the savings are going to be sufficient and the paybacks are going to be reasonable, we would request the customer to let us come into the facility, spend a couple of days on site, and collect a lot more of the data that we need for a more detailed analysis. And that allows us to prepare a formal proposal through what we refer to as an investment grade audit.
So if I'm hearing this correctly, either a phone call or a data capture form with some questions. It sounds like there are about a dozen questions.
Yes,
It's not
that
a
is correct.
10-page document. It's a
That is correct.
one-page file. So with that, it's like anything. If you know what you're starting with, you can help guide them on what could be achieved.
What could be achieved. And then we can prepare a more formal proposal of the savings, provide the savings guarantee and the time frame of installation, which is only about 2 or 3 months at most.
Is there a cost to have that preliminary assessment, or is that some part of just the course of doing business?
That is part of our proposal preparation process, and there's no obligation on the customer's part until they agree to let us install our technology.
Understood. Okay, so let's say that they've gone through, they provided on a call or through this data capture form some information. You come back within a few days or a week with
Within a week, yes.
enough to be dangerous, and then from that point, if they like what they see, you would potentially schedule a site visit to go to the physical building.
That is correct.
Okay, and from that, if it's an afternoon or a day or two, you come back within another week or two, or how long is that next phase?
Probably a couple of weeks,
Okay.
because we need to not only collect all the data on the existing equipment, but also how that data is currently being provided or not provided in the building management or building automation system. And we have to then figure out how we're going to interlink our technology with the existing equipment and the existing building management system.
Is there a cost for that typical investment grade audit as well with that deeper dive proposal?
The investment grade audit is done at our cost with no obligation on the customer's part.
So now that that's been completed and you're maybe a month into the relationship and they still haven't spent any money, if you show them that proposal, it's going to be a more accurate, I guess, reflection of what the monthly savings would look like?
It is, and in fact, it is guaranteed. We guarantee either the savings or the payback or both. As part
Because
of
you've
that
done the
proposal.
deep dive.
Right. Well, at that point, if they accept the proposal, they're essentially committing to pay us when we complete the project and demonstrate the savings.
You call that a letter of intent, or what's the structure of that?
That would
agreement?
actually be a contract between us and the customer,
Gotcha.
which specifies the terms of our engagement in terms of what we will do, what we will specify, and how we will measure the savings. And that once the savings are confirmed, they would have selected either the one-time payment option or the payment through savings option for multiple years.
I can imagine if I was in the position of a CFO of a major, hospital or university, any of these bigger buildings, that I might want to see the savings delivered and then consider an option to purchase the system itself. Is that something where you could choose to, in the beginning, see the monthly savings and then opt to purchase the service outright?
If you do go with the option of paying through savings, then at the end of each year, there'll be a 5-year contract. At the end of any year, the customer will have the option to buy out the system
Great.
for a certain price, which we'll specify in a schedule.
Tell us how you measure the savings.
The measurement and verification protocol we use is something called the International Performance Measurement and Verification Protocol, which is accepted in 30 different countries. It was, of course, developed in the US, and that specifies how the measurement and verification is to be done. Generally, we would look at 1 year's historical data and relate it to weather or other conditions. And then once we install the system, we will compare the consumption after installation against the consumption prior to installation for a comparable set of conditions, whether it's the same month or the same weather conditions.
That's great to hear, because sometimes, for example, I'm just envisioning a hospital that might have opened, maybe it's a NICU wing for the children, and like what ends up happening is they use more energy in one particular area. So the level setting becomes just something you have to mutually agree with, I guess, the customer, that you're
Correct.
measuring the same things.
And if there are too many changes in the facility, one other way to simply measure the savings is to run the chiller system with our technology for 2 weeks of the month and run the same system without our technology operating for 2 weeks of the month. And this is something we've done to actually show the significant difference in the consumption with and without our technology.
I like that because again, one of the questions in performance contracting is, what is the performance based on?
Baseline is a very important thing here. If we can get a good baseline that is agreeable, that is agreed to between the customer and us, it makes things very simple. But in some cases where the system has gone through major changes, for example, one of our customers installed a new cooling tower after we had installed our system. So the previous baseline was no longer valid. We have to now create a new baseline.
Understood.
We were able to do that not by creating new baseline, but by measuring the consumption with and without ECORE for 2 weeks in the same month.
You can also talk about how if there's a facility like a distribution center for beverages that has a big refrigeration component or food processing.
Food processing where they have very cold temperatures and are using ammonia-based refrigeration systems, yes, we can also apply our technology to that.
I don't know if people want to feel like there's brain power at work that's outside of their control. Can they monitor and manage or turn off and on at certain times or test themselves how this is working? Talk about that user interface.
This is very similar to what an operator would do with the building management system. That is, he will be able to see on his screen all of the different parameters of the chiller operation. He will see the flows, the temperatures, the pressures, and so on. And he will be able to see what is happening with that chiller system in terms of how it is running. If he sees that something is not running right, he can always switch off our system, go back to his manual operation. And what we are doing is not any different than what he's doing, except that we are doing it continuously. Every 5 or 10 minutes, we're changing the parameters based on the chiller loadings, the ambient conditions, and the user requirements.
So he is driving the car if he wants to, he or she.
Yeah, he's at least has the steering in front of him.
Algorithms make autonomous smart vehicles possible. Algorithms make energy intelligent smart buildings possible. If the end of the month comes after the system has been commissioned and the customer and you all agree that the savings were matching what you had predicted, do they then cut the first monthly check in the second month after they've seen the results?
Well, if they've elected the one-time payment option, they'll pay us the whole thing at that point.
Okay.
But if it's the payment from savings option, then essentially they'll cut a check either monthly or quarterly, depending on how we have the size of the facility and the size of the investment. That will determine whether it's monthly or quarterly payments. We would prefer quarterly payments. So they'll wait for a quarter and then pay us at the end of the quarter.
So if I'm hearing this correctly, the phase one savings analysis is done on your time. The deep dive investment grade audit is done. Writing all of these algorithms over multiple weeks or months, depending on the size.
4 to 6 weeks, yes.
4 to 6 weeks. Commissioning it, benchmark and testing it for at least a month, and they may not pay until the next quarter, three months out from when it's commissioned. So again, pretty incredible from the standpoint of a CFO or an executive in a C-suite. Let's talk a little bit about this technology that is patented. So I read online it was granted in 2014.
That is correct.
U.S. Patent Trademark
Yes.
Office. And did you get started before that?
Well, we of course had been developing the technology for several years, and the patent application was made late in 2010. It took us about 3+ years to get the patent approved, which is normal in the case of U.S. patents. Some of our early installations were made in a group of 5-star hotels belonging to the Starwood Group. These are located in India and were all very efficient to start with. The hotel CEO prided himself on the fact that they were the most energy efficient hotel chain in the world.
Wow.
And challenged us to say, hey, if we are already most efficient, what else can you do for us? And after we installed the first one under our cost and measured it for 6 months and got paid, he then gave us 8 other hotels to do, because he was now convinced that even with a LEED Platinum certified building,
Wow.
there was room for additional savings.
Well, that's terrific to hear because, again, people often don't want to go first.
Yeah, the longest operating system currently is about 5 or 6 years, and there's been no issue with that. We have not had to go there and do any retrofit or any recommissioning at all.
Here's a case study of a LEED Platinum hotel. It's a flagship hotel of the ITC chain of the Starwood Group. Prior to ECORE, it was already one of the most energy efficient hotels in the world and was LEED Platinum certified. The ECORE installation saved about 30% of cooling energy, and the payback was about 2 years. This chart illustrates the advantage of warmer climates where the savings is greater as the temperature increases. This case study is a luxury hotel, 392 guest rooms, cooling capacity of 700 tons. The annual use was 4 million kilowatt hours, and the savings came in at 1.3 million kilowatt hours. That's over 30%, and the payback in 2 years. This luxury hotel saved 7,664 kilowatt hours per day. This case study is for the Johns Island Club in Vero Beach, Florida. It integrated with Johnson Controls' Metasys BMS system. The ECORE installation saved over 40% of energy cooling costs. It was implemented using the licensing model, which is savings payments versus upfront cost. The energy savings is over 1,000 kilowatt hours per day. For this district cooling plant in the Middle East, the cooling capacity was 25,000 tons, 10 chillers at 2,500 tons each. The cooling cost per year was $3.2 million in US dollars, and the savings generated by ECORE is over $600,000 a year. That's 15 million kilowatt hours per year, saved at just 4 cents per kilowatt hour. So there's even more savings in the US with higher kilowatt hour rates. This chart illustrates the advantage of ECORE, where there's significantly higher costs without ECORE than with the system. Here's some more reasons to say go to energy intelligence. Number 1, the utility incentives. Many utilities offer rebates for energy efficiency. Number 2, tax incentives. HVAC improvements are expensed versus depreciated with 179D of the IRS code, restarted January 1, 2018. Number 3, sustainability goals. Reach them more cost effectively than with other measures. Here is a key point. The guaranteed savings are on kilowatt hours and not inflated with subsidies. ECORE-CI dynamically adjusts the chiller system operational parameters to meet the constantly changing cooling loads, that's user requirements, and the ambient conditions such as temperature and relative humidity. ECORE-CI reduces the condenser water entry temperature, CWET, to the lowest level permissible under ambient conditions, thereby reducing the outlet pressure of the compressor P2, which substantially reduces compressor energy consumption. ECORE-CI balances the chiller load across multiple chillers to achieve the chiller manufacturer's published optimum kilowatt per ton per the defined condenser water entry temperature. This all adds up to maximum savings. The algorithm intelligence includes small adjustments for big savings, with over 25 million kilowatt hours saved per year.